Good morning. We are going to start talking about Chapter 9, Section 8, which is discussing compound events, and the page numbers go along with the work that you guys have. So make sure you're doing that and turning it in whenever you're done. So just a couple new key terms, and there's another one towards the very end of the PowerPoint as well. So we're still talking about probability, still talking about events happening and that type of thing. So just a couple of terms to talk to you guys about and kind of explain things, or if a question says find the independent event, you know what it's talking about. So the first one is kind of the title of this section. It's talking about compound events, which consist of two or more simple events. So what that means is when you guys have had questions like rolling a number cube and flipping a coin, or flipping a coin and spinning a spinner and landing on a color. Those are compound events. So there are two things that are happening and two things that are going on that you're finding the probability of happening. Then there's what is called an independent event. So the outcome of one event does not affect the outcome of the other. So if I'm asked to pick from a pile of coins and then flip the coin that I picked. So the outcome of flipping the coin isn't affected by what coin I picked. It doesn't matter which of the coins I picked. I can still, just because I picked this coin doesn't mean I'm going to land on heads, or just because I picked this coin doesn't mean I'm going to land on tails. And then there's what is called a dependent event. So if the outcome of one event does affect the outcome of the other. And we'll go over examples of all of these. Kind of a quick example of a dependent event is if I'm picking marbles out of a jar and I pick one out, and then I pick another marble out without putting the first one back. It then changes my total amount of marbles that are in the jar for the second time I'm picking, and how many options of certain colors there are, because I've now pulled a marble out and I didn't put it back. So we're going to go over an example that's actually on marbles, so that'll make sense in a little bit. So looking at this first example, this is an independent event. So the example is over here. It says a coin is tossed and the spinner shown is spun. So the spinner has letters on it, so A, B, and C. And then it says find the probability of tossing heads and spinning a consonant. Okay, so not a vowel. So your choices of spinning a consonant would be if it lands on B or on C. So one way you can do this is to list out the sample spaces, or list out the outcomes that you could have. So if I'm flipping a coin and then I could either land on A, B, or C, I could land on heads and spin an A, land on heads and spin a B, land on heads and spin on C, and then tails and A, tails and B, and then tails and C. So this is just the abbreviation, and I kind of mentioned that yesterday. So the probability is what that P stands for. And what I'm trying to find is it landing on heads and a consonant. And I spelled that wrong right there. I put consonant. Sorry, guys. So looking through your list, landing on H, so I can cross everything out that has a T in it because I don't need to worry about those. And then I know that A is a vowel, so I can cross that out as well, which leaves me with just the HB and the HC. So I have two ways that I can land on that. And then the bottom number would be 6, because I had a total of 6 outcomes that you listed. So your answer is 2/6 or 2 out of 6. But remember to always simplify that. So on that one, I can simplify to 1/3. Looking at another example, and this is also an independent example, yes, this is also an independent example. This one's a little more not complicated, but pay attention to what it's asking. it's one of those math questions that gives you an explanation and then says something and then asks you a completely different question. So just pay attention to what the question is asking. So it says, Brianna is buying a new outfit. She is choosing among 2 red, 1 purple, 3 pink, or 4 yellow tops. For pants, she's choosing between jeans or capris. If Brianna chooses a top and capris at random, find the probability that she chooses a yellow top and jeans. So that would be why I said that question's kind of confusing, because she chooses a top and capris, but it's not asking about that. It's asking to find the probability that she chooses a yellow shirt and chooses jeans. So again, I'm trying to find the probability of finding a yellow top and jeans. So on this one's a little bit different. I'm finding 2 separate events since they're 2 separate things. So picking a shirt is separate than picking a pair of pants. What I pick for a shirt won't determine what type of pants she's picking. Okay, so as far as picking a yellow top, if you look back in the question, she could pick from 4 yellow shirts. And then the 10 on the bottom is the total number of shirts. So there were 2 red, a purple, 3 pink, and then 4 yellow tops. So 2 plus 1 is 3, plus another 3 is 6, plus 4 would be 10. So she has a total of 10 tops to choose from. So the probability of picking a yellow top would be 4 out of 10. And then for picking jeans, there's 1 options of jeans, and she can either pick from jeans or capris. So she only has 2 total options that she can pick from as far as pants. So she would have 1/2. And then you're actually going to multiply these 2 things together. So remember, when you're multiplying fractions, you don't have to have a common denominator. You can just multiply the 2 numerators, or the 2 top numbers, and then the 2 denominators, or the 2 bottom numbers. So when I multiply 4 over 10 by 1 over 2, I would have 4 times 1 is 4, and then 10 times 2 on the bottom is 20, and then I can simplify that to 1 over 5. So the probability that she chooses a yellow top and jeans is either 4 out of 20 or 1 out of 5. So this is now an example of a dependent event. So this is the example of the marbles that I mentioned earlier. So the question says there are 2 red, 5 green, and 8 yellow marbles in a jar. Martina randomly selects 2 marbles without replacing the first marble. What is the probability that she selects 2 green marbles? So the key word in that is without. So she doesn't replace the marble that she's picked. She pulled it out. Now what's left in the jar has changed. So I'm finding the probability that both are going to be green. So I'm actually finding 2 probabilities like I did in the last question. So the probability of the very first marble that she pulls out being green would be 5. There are 5 green marbles, and then out would be out of 15. That's how many total marbles I have. So 8 yellow plus 2 red would be 10, plus 5 green would be 15 total. But then the second one gets a little bit tricky, and just make sure you pay attention to these questions when it says I didn't replace, or I didn't change something, or I didn't put it back. However it's worded, if it's not replaced, you need to now think about what your new total is in the jar. So if I didn't put a marble back and I've pulled 1 out of 15, there are now only 14 marbles left in the jar. And if the first one I pulled was green, I now only have 4 chances of pulling a green marble, since I didn't put that one back that I pulled. So that would be the probability of the second marble would be now 4. There are 4 green marbles left out of 14 because I've now pulled 1 out, so my total decreases as well. So again, you're going to multiply these 2 things. 5 times 4 on the top is going to give you 20, and then 15, and this should say 14. I'm going to go ahead and change that so we don't have that issue. Then 15 times 14 on the bottom is going to give you 210, and then you can simplify that. Both of them are divisible by 10 since they have a 0 at the end, and I can simplify it to 2 over 21, which I can't simplify anymore. 2 can't go into 21, so it's as small as I can get it. So the biggest thing on these questions is make sure you're changing that total number whenever you go to multiply or whenever you go to write the probability. If you're not putting something back, your total of what you have has now decreased by 1 or 2 or however many it's asking you to take out in the first question. Okay. And then this is our last question, and this is kind of the last key vocabulary word. You won't see, this is kind of what you guys have been doing, you just didn't know the name for it. So this is what is called a disjoint event. So they're events that cannot happen at the same time. So I can't, if I'm rolling a number cube, which is the question in here, I can only roll one number. I can't roll a 6 and an odd number at the time, or a 6 and an even number, or a 1 and an even number. So those are things that can't happen at the same time, which is why it is called a disjoint event, and this is kind of why that's an example of that. So it says a number cube is rolled. What is the probability of rolling an odd number or rolling a 6? So a 6 isn't an odd number, which is why they can't happen at the same time. So the probability of that happening, I have 4 possible outcomes. So a number cube is 1 through 6. My odd numbers would be 1, 3, and 5. And then I also, it says or a 6, so I'm going to add that 4th one in there. So I have 4 outcomes or 4 chances of that event happening. And then I have a total of 6, because there are 6 numbers on a number cube. And then I can simplify that to 2 over 3. So the chance of, or the probability of rolling an odd number or a 6 would be 2 out of 3 chances. Okay. If you guys have questions, please let me know. I'm more than willing to help you out. I know that this can be kind of confusing. So if you need help, please let me know, or you're confused by a question, or you don't understand one of these words or what you're actually trying to find, just let me know. Have a great day, guys.